वेबिनार शुरू हो रहा है मेरा।
अच्छा, छोटी सी एक डिस्कशन कराऊंगा। वो कुलकर्णी जी को हमने हायर किया था, कंसल्टेंसी फीस लेके।
हेलो, वेबिनार शुरू हो रहा है मेरा।
अच्छा, छोटी सी एक डिस्कशन कराऊंगा। वो कुलकर्णी जी को हमने हायर किया था, कंसल्टेंसी फीस लेके।
हेलो, वेबिनार शुरू हो रहा है मेरा।
अच्छा, छोटी सी एक डिस्कशन कराऊंगा। वो कुलकर्णी जी को हमने हायर किया था, कंसल्टेंसी फीस लेके।
हेलो, Introduction to EverestVacuum, categorization of vacuum pumps. How do we categorize vacuum pumps? Vacuum pumps, we'll be talking in detail on most of the technologies that are used in chemical and pharmaceutical companies in detail. We will be discussing the rule of 2030. We will be discussing on a lot of case studies, different sectors, just to get a variety of all the sectors. Not all, I would say, but to quite an extent, a good bunch of sectors that we cater to. We will be discussing about a very important concept, that is the total cost of ownership and its importance. We will also be discussing about contaminants and how do we control these contaminants. Then we will be coming on to the conclusion. And then we'll have a brief Q&A, question and answer session. We'll also have a free one-to-one strategy call. Last time also we had enrolled or initiated this program, but we didn't get too many enrollments here. So this time we would like to push it even more, wherein people can contact us and use our expertise and experience that we have gathered over the years, wherein we tell them on all topics that we are covering in the contents over here. So technical services and consultancy, this is EverestVacuum established a dedicated cell that is working in close association with our customers, and in this technical and services TSG group, we are mainly concentrating on 4 key objectives. First objective is selection of the ideal vacuum pump of choice in accordance to the process. Now, every process, there is no pump that is right, there is no pump that is wrong, but there is one most efficient method of doing in that particular process. So here, this services group, TSG's responsibility is to educate our customer on what is the right choice of doing that process. Second is calculate and optimize operational cost. We will be able to tell to our customers what is the cost of operations that they can expect from various different technologies based on some benchmark figures that we collect when we talk to industry experts. Point number 3 is right sizing of vacuum pump for best results in terms of productivity and cycle times. So how to right size your vacuum pumps When do you use a bigger size backup vacuum pump? When do you use a smaller size backup pump with a booster on the top? How can you actually optimize your cycle time? So all of this is covered in this point. Apart from this, we help our customers decide what should be their desired operating vacuum levels, and if they change their vacuum levels, how will it affect their yield, oblique product quality, oblique operational cost. So all these three go hand in hand, and the customer will be able to very clearly identify that what is the best after he gets in contact with us. He'll be able to have a very clear thought as to what pump, what vacuum should he be using, and what can be his expected operational cost. So first, coming back to our mission 555, wherein our mission is to provide innovative engineering solutions in the entire range of vacuum by having state-of-the-art technology, optimized designs, excellence in R&D and manufacturing, with a dedicated team focused on training and development of our employees, of our products, continuously expanding our operations in markets and possibilities of collaboration to service our customers better. So that is our mission 555. We dream to grow from 50 crores to 500 crores within the next 5 years. So a brief about introduction. On the original day, all these slides will be dealt by Mr. Ahuja. Today, just to save on time so that we can wrap up in the next, within the hour, is why I am covering all the slides. So our offerings are dry screw vacuum pumps, mechanical vacuum boosters, industrial engineered vacuum systems, liquid ring based semi-dry vacuum pumps. Why we call these as semi-dry? Because we focus on closed loop recirculation. We don't consume even 1/10 of water which is being consumed in conventional liquid ring based technologies. Oil ring, again, we call these as semi-dry systems. Rotary vane vacuum pumps and systems. Low temperature thermal evaporation, which is majorly zero liquid discharge and MVR technology. These are some of the product photos of various products that we have on offer. And then coming to our promise, that what we actually promise to our customer and what we stand to deliver. So we stand to deliver clean, reliable and sustainable vacuum, improved product yield, deeper and consistent vacuum, cost and space saving by right sizing, reduce batch cycle times, reduce operational cost. So these are some of the promises that we promise to our customers. Now coming to fundamentals of what is vacuum. So vacuum, as you all know, is space devoid of matter. It is a Latin objective for vacant or void. Emptiness is vacuum. And then we have various classifications of vacuum. So you have atmospheric pressure, then you have low vacuum, then you have medium vacuum. When I talk about CPI, that is chemical process industry, our core focus will be either on low vacuum and medium vacuum. When we go to research or we go to ultra clean applications, there we need to go up to a high or ultra high vacuum, and then we have outer space. So and then we have perfect vacuum. So even space is also not perfect vacuum. Today we will be limiting our discussion to low and medium vacuums. I have unmuted all of you. in case you want to ask me anything or have any questions, you can either type it in the chat or unmute yourself and speak. So why vacuum is needed in a chemical or a process industry? Vacuum system can affect various aspects of processes such as utilities, consumption, process times, quality, safety, and environmental impact. Benefits of right vacuum pumps. So like you saw in the previous slide, that what all parameters it affects. If we don't choose or make the right selection of vacuum pump, what do we lose on? So 6 key advantages when we choose the right type of vacuum systems. Number 1, reduced energy consumption. Number 2, reduce risk of heat damage to sensitive products by lowering process temperatures. Most of the cases, vacuum is applied because material is thermally sensitive. They don't want to go beyond a particular temperature. Like in Aurobindo Pharma, I was just attending to a person right now, and we were discussing about an application in Aurobindo Pharma where their material is only 45 degrees. So they cannot cross 45 degrees. So there they tell us that you do all our processes at 35 degrees to maximum 42 degrees. 7-degree delta range they have given us. Third advantage, enhance product quality through impurity removal. As we keep moving towards medium vacuum, that is up to 10 raised to power minus 3, we keep improving on the product quality as we are removing impurities from the process. Fourth, safer operating atmosphere through oxygen exclusion. Now, in many applications, many reactions, oxygen creates a havoc. Product oxidizes. So there they want removal of oxygen so that there is no oxidation that can take place. Increased yield by shifting reaction equilibrium. And 6th point, simplified product transfer in pneumatic conveying and lifting. So the 6 key advantages why vacuum systems are chosen are listed here. Right sizing of vacuum systems and its importance. So how do we rightly size our vacuum systems and why it is important? Number 1, designing of vacuum systems, selection of the right vacuum pump. Number 2 is piping, sizing and MOC. Number 3 is automations and controls and selection of the right accessories. So while designing any vacuum system, these parameters play a very critical role. Advantages that are there with right selection, ensuring process objectives are met. Number 1 is vacuum levels are achieved. Pumping speeds that are desired, pumping speeds are achieved. Why do pumping speeds become important? If we have the right pumping speeds, we will be able to achieve the right cycle times. Smaller pump, cycle times will become very high. A bigger pump, maybe we will not be able to complete the process as per our desired requirements, or we will be spending extra power. Budgets are met. So you can do, say, a job at 5 torr. Now I come across some customers who tell me I want to do this same job that I can do at 5 torr at 2 torr. And my simple answer to them at that time is that if you want to move from 5 torr to 2 torr, don't assume that you are doing a delta of only 3 millibar. When I am calculating the vacuum system, I will have to double the size of the vacuum pumps because 2.5 into 2 is equal to 5 torr. So I am going lesser than 2.5 torr. I will have to put 2 times or more than 2 times bigger vacuum pumps for you. So customer needs to be very specific onto what his requirement is. It is not like it is a utility. People should start seeing vacuum as a utility. When they start, it is not a luxury. So more or less is not the question. What is the right amount of vacuum that is required for the process? Arriving to this decision in itself is a very big task. But once you arrive at it, then greatly the right selection of vacuum pump becomes an easy choice. So continued right selection of vacuum pumps. Three key factors that we need to consider while making the selection. A is load. Load can be of two various types, vapor load or the condensable load, and then can be the non-condensable load. Non-condensable load can also be categorized as leakages. Leakages are also non-condensable loads. B point is system volume. And then you have C, which is the ultimate vacuum that is required. So all these parameters make it very important to decide on what should be the key factors while making the selection for the right type of vacuum pump. Now this slide I am planning to exclude. This is from the previous webinar, but I'll be excluding this slide this time. Types of vacuum pumps, then is classification. Now what we have covered till now is why selecting the right type of vacuum pump becomes important, A, and how or what all parameters to consider while making selection of the vacuum pump or the vacuum system. Now we will go to phase 2, that is categorization, which all different type of vacuum pumps are available for us in the market. There are two types of technologies that are available. First is called as the wet technology pumps. Wet technology pumps has different categories. What is categorization of wet technology? So wet technology requires lubrication fluids such as oil and water. The lubricant fluid must be changed regularly and disposed of appropriately as it becomes contaminated with process fluids. Then comes the dry technology vacuum pumps. Dry technology vacuum pumps are categorized as pumps which require no lubrication in their swept volume. That is, on their process contact parts, the main chamber which does the compression, there is no external lubricant that is available. And this gives the advantage of lower environmental impact, requires less maintenance, and more reliable than wet technology pumps. The advantage that this type of vacuum system has is that these type of systems can be used in very aggressive environment as well. In most aggressive environments where you are using or pumping corrosive gases, there as well we can use this type of a vacuum system. Just a second, I am opening up this presentation on another computer as well so that I can see two screens. Yeah. So vacuum pumps, for the purpose, we have covered types of vacuum pumps, categorization of vacuum pumps. Now, most of the vacuum pumps that are used in the market are positive displacement pumps. What are positive displacement pumps? Positive displacement pumps are pumps that operate in low vacuum and medium vacuum ranges and exhaust to atmospheric pressure. They are either termed as meter cube per hour or CFM. Because these pumps discharge to atmosphere, they are termed as primary pumps. These pumps can either typically be used alone or they can be used along with a secondary pump that creates higher vacuums or more pumping speeds. Now these secondary pumps are typically boosters, primary pumps are typically dry screw pumps, liquid ring pumps and such technologies. So the positive displacement pumps, gas is trapped, this is the evacuation chamber, and you have multi-stage pump. First pump does some compression as compared to the gas chamber, sends it to the second pump. Second pump further compresses molecules and sends it to the backup pump. Now the backup pump or the primary pump will do its own compression and discharge out into the atmosphere. So type of vacuum pumps, I am again covering the same vacuum pumps. First, I covered these vacuum pumps in a category that what are wet pumps and what are dry pumps. Now I am covering it in another way, that wet pumps, how can we categorize them? So wet pumps can be categorized into four major categories: steam ejectors, water/air ejectors. These are not very popular, but there is a category that exists. Liquid ring vacuum pumps, oil sealed pumps. Oil sealed pumps can further be categorized into two: rotary vane and rotary piston. The advantages of these type of pumps: initial cost is low, and in some cases they offer robust performance. And because this technology has been available there in the market, it is widely spread. Now coming to dry vacuum pumps, which are non-lubricated, non-contact type mechanical impellers. So basically any pump which has no sealing fluid inside the working chamber is categorized as a dry vacuum pump. The pumps that are mechanical vacuum booster, dry screw vacuum pumps and claw pumps are the three major popular pumps that are available in this category. There are pumps that are there available in high vacuum applications as well, such as turbomolecular pumps. But because today's webinar, we are limiting to chemical and process industry, so our preview of selection of pumps is limited to this category. The major advantages that these pumps offer over any other type of vacuum pump is there is no water, oil or sealing fluid. There is no process contamination or effluent generation, and they are suited for chemical and process industry. These pumps are not typically suited for chemical and process industry. They are a makeshift. If people are using these pumps, they are compromising. They are not built for chemical and process industries. These are built for clean vacuum applications. Whereas these pumps have specifically been developed keeping in mind the requirement of chemical and process industry. Now, starting from, we've already made the categorization. First pump that comes in wet pump category is the steam jet ejector pump. Now, how does a steam jet ejector pump function? So a steam jet ejector pumps has three basic parts: the nozzle, the suction chamber and the mixing chamber. High pressure motive fluid, usually steam, passes through the nozzle, enters the low pressure. So this is the nozzle, this is the nozzle, this is the suction chamber. So this is the suction, this is the nozzle, and this is the mixing chamber. We pass high pressure steam from here. That high pressure steam, when it expands, it creates vacuum. Because of that vacuum, there is heavy suction that happens here. Both steam, that is process vapor and steam, mix here, and further when they pass through this venturi, they further expand and move on to the next stage of the condenser, next stage of the ejector. Now here, this is a cut section of a typical steam ejector, and here, if you see, is different stages that exist. So you have a steam jet ejector which will start from W, then it will come to X, then you will have a condenser in between, then it will go to Y, and then you will have another condenser in between. and these condensers are being bagged, or their vacuum is being created by a liquid ring backup pump. Now, typically, customers use 2 to 3 stage steam jet ejectors, which we call as multi-stage ejector. The disadvantage in such cases is that the customer has to use an interstage condensation. So whatever process material that the customer is getting, be it vapor, it mixes with the steam, condenses in this condenser, and a lot of effluent gets generated. If, like in this particular case, so here in Y stage, what I have tried to highlight from this picture is, in Y stage, steam consumption will be very low. That is why relatively the size of this condenser is very low, because it has a pre as well as a post condenser. But in case of W stage, when the customer has to go to 4, 5 torr, so typically this being a 3-stage ejector, we'll be able to achieve anywhere between 5 to 25, 30 torr. But what will happen, there will be so much of steam consumption at this stage that the whole process will cause very high operational cost. And because all of this steam is getting mixed with process vapor, it will generate high effluent. So here I have written, unless process vapor is same as motive fluid, large amount of effluent gets generated. This is the biggest drawback what a steam jet ejector has. Probably 20 years before, when we were in 1980s, 1990s, this was the technology to be, because this was economical, this was robust, steam was easily and cheaply available, fuel was very low cost. But as we are advancing, as mechanical pumps are advancing, this technology is fading out. Some advantages that this technology offers: it still has very high reliability. It is robust in corrosive environments. Now, when I say robust in corrosive environments, it is very robust when I am talking about alkalis. But as soon as I start talking about acids, it creates a problem, because when steam mixes with, say, hydrochloric acid or some nitric acid, it creates a aqueous hydrochloric acid solution, which is 3 to 4 times more corrosive than concentrated hydrochloric acid itself. So in that case, we need to start going in with special exotic metals. High suction capability. Steam jet is typically used in applications which are very big, where very high pumping rates are required, where mechanical pumps till about 10 years back were not the preferred choice. But with very fast advancement happening in mechanical pumps, like say probably 3 years, 4 years ago, the biggest booster that Everest was manufacturing was, say, 5,000 meter. So if a customer required 40,000 meter cube, he had to put 8 boosters in line. But with our EVB 300 coming in, which offers 18,000 meter cube, if he requires 40,000, he just needs to put 2 now. So their economies of scale are coming in. Probably at that time, if the customer would have demanded 40,000 meter cube, we would have had to tell him, either boss, you use 8 boosters in parallel, or you use a steam jet ejector. And the first cost is low. Disadvantage is, operational cost is very high, effluent generation is very high, sensitive to variation in processes and pressure, low thermal efficiency, and very high operating cost. Initial cost, first cost is very low, but total cost of ownership if I talk, or operating cost if I talk, so total operating costs are very high. Then second category, second classification in wet category of pumps is the liquid ring vacuum pump. Now this pump is also a very, very popular pump. Liquid ring vacuum pumps compression, typical compression ratio will start from say 10:1 in single stage and go up to 30:1 in double stage. The ultimate vacuum that is there in the liquid ring vacuum pump depends upon this. This is the sealing fluid. This blue material that you see, the blue ring, this is actually the sealing fluid. This sealing fluid can be in multiple options. The only requirement has to be that it has to be a low boiler. You cannot use it has to be a high boiler. You cannot use low boilers. You cannot use, typically you should not use acetone or boilers which start evaporation at 60, 70, 80 degrees. Why so? I'll tell you further. Typical, most commonly used sealing fluid in this case is water. The other option that is very popular is oil. Now I'll show you over here liquid ring pumps, why they are popular, because they offer capacities of up to 50,000 meter cube per hour. So the big plants like paper mill industry, some big petrochemical plants where you require low level of vacuum but high displacements, these pumps become the ideal choice. If you are using water, the ultimate typical vacuum, presuming you are running it in India, where the average temperature, cooling water temperature is 30 degrees, you will be able to achieve 33 millibar. And if you are running with oil, you will be able to achieve 10 millibar. Now, liquid ring vacuum pumps, when they are combined with mechanical vacuum boosters, offer exceptionally good pressures. Now, pressure means vacuum, low pressures. So these are either consumed along with a mechanical vacuum booster or consumed along with a steam jet ejector booster to get low pressure operation. The liquid ring vacuum pumps are robust in design, can handle good amount of containments, and the basic advantage is they are manufactured in vast variety of materials. Some advantages that they can handle high vapor temperature loads, they offer low noise levels, low vibrations, and variety of materials for wide chemical compatibility. But still, with all of these advantages, why liquid ring vacuum pumps are still not the preferred choice for chemical process industry. Now, when I say chemical process industry, it includes all pharmaceutical industries also, because they are also manufacturing chemicals at the end of the day. So any agrochemical, any pharma, they are all categorized in CPI category for us in the field of vacuum. Disadvantages that these pumps offer are that if most of the customers who are using these pumps are using these pumps on the concept of once through liquid ring pump, wherein the sealing fluid will pass through the pump only once and it will be discharged out. Either it will go into the drain or it will go into a ETP or a STP plant. The power consumption is high. Now, why power consumption is high? Because a ring of liquid has to be formed. It is like you are churning a full glass which is full of water with a spoon. So the amount of energy that you are spending is much higher than you would have actually spent if it would have been an empty glass. Because of the fluid, you have to spend more power. The ultimate vacuum in any liquid ring pump is low because it is ultimately dependent on the sealing fluid temperature, the vapor pressure of the sealing fluid, either water or oil. And when you start going to very high vacuum levels, you start facing a very common phenomenon that is called as cavitation. Now, cavitation is like flash evaporation. It is evaporation of sealing fluid from one point itself, and it is irrespective of the base metal. It can be either cast iron or stainless steel or titanium. All are subject to cavitation. The next category of pumps that are there are oil sealed vacuum pumps. Now, oil sealed vacuum pumps are slightly better as compared to liquid ring vacuum pumps. They offer higher levels of vacuum. The principle I have explained here, but I am not going to detail. Am I still audible? Hello.
Yeah, now it's better, Dhruv. Now we can hear you. We can't see you, though.
You can't see me.
No, there's something wrong, Dhruv. Yeah, now it's okay. Yeah.
Can you see me now?
Yes, we can see you now. Yes, please continue.
अच्छा ये बीच में इंटरनेट स्लो रहा है.
Something was wrong. So we kind of couldn't see you, couldn't hear you for a brief, let's say some 15-20 seconds.
Oh, okay. Okay, no problem. I'll still continue.
Sorry for the interjection, Dhruv. Even now also your screen is coming unclear. Now it's improving. Okay, maybe it's a connection. Yeah, it's improving now. So we can, even still now, it's not 100% clear. It's
going blur in between.
Yes. Even now the screen, your screen is not 100% through.
Okay, we've just got a new connection today. Maybe let's see. I am just switching my internet. Yeah, hello. I have just switched my internet to another connection. Let's see how this behaves now. Okay. Can you hear me?
Okay. Yes, we can hear you. Continue, please. Yes.
And is my screen better?
It's better, but still not 100%. It's like 80-85%. It's a bit, just a shade hazy, better than what it was earlier, but still not 100%.
Okay. Chalo, I'll be moving forward. Now, the next technology that is there is the oil sealed vacuum pumps. The oil sealed vacuum pumps can be categorized into two different parts. The rotary piston, where you have one single piston that rotates inside the impeller, and the rotary vane pumps, where the vanes slide in and out. In both the cases, the rotors are eccentric. Now, these eccentric rotors rotate inside eccentrically inside a fixed volume chamber, and when they rotate, they create different volumes, because of which there is expansion and compression, which ultimately leads to creation of vacuum. In such cases, oil is used as the sealing fluid. The advantages that these type of pumps offer: number one, lower effluent generation as compared to liquid ring pumps. Number two, high vacuum levels. Number three, they are compact. Vibration levels are low, and they are best suited for clean applications. The disadvantages that are there in such cases: A, operational cost is very high. Environmental hazards, as oil vapor contaminating surroundings is high. Backstreaming of oil can reduce process cleanliness, and oil contamination with process fluids can cause deterioration of oil and frequent failures. So all of these pumps, till now, the three technologies that we discussed, because all three technologies had their own pluses and minuses, and chemical industry wanted even better solutions, led to dry pumps coming out. So the most popular, most reliable dry vacuum pump is called as the mechanical booster. Now, this particular pump enjoys a very unique characteristic, which is commonly termed as the bell-shaped curve. This is the bell-shaped curve. The only disadvantage being that this booster cannot work on its own. It needs some form of backup pump, be it a screw vacuum pump, be it a liquid ring pump, be it a uh, ejector. Any type of backup pump should be there to assist this type of a pump. Once put on top of the backup pump, so this is the curve of the backup pump, say a 300 or a 400 meter cube per hour. In combination, if you put a 50 booster, which is a 3000 meter cube booster, so you get a bell-shaped curve. You'll be able to achieve much higher, maybe almost 10 times higher pumping speeds as compared to the conventional backup pump alone. The operation of principle is very simple. It is a once through pass pump. It is also termed as a dynamic valve pump. Vapor comes in, moves out. Similarly, vapor comes in and moves out. The advantage is 100% dry pumping, quiet and compact operations. The pumps enjoy a long service life. They are robust in design. Clean pumping is available through this pump because there is no sealing fluid. It is 100% dry. The working chamber is 100% dry. And you can expect great or huge power savings as compared to conventional pumps. Now this pump, because of its unique pumping characteristic, the amount of pumping that it does versus the price that is there, price works in its advantage. The other type of dry vacuum pump that we are going to be covering today in our webinar is positive displacement pump, which is the dry screw vacuum pump. Now this is the latest technology in advanced that we have to offer. We offer a hybrid variable pitch screw pump technology that has been dedicatedly developed for the chemical industry. And in further slides, I'll be covering why it has been dedicatedly developed for chemical industry. This pump meets the requirement of clean, reliable, flexible vacuum with low total cost of ownership. This pump also has very good liquid handling capacities. So you can pass decent amount of liquid through the pump without any effect coming on to the pump. The pump is very robust and is good in coping up with any upsets that are there available in the process. Typically, the pump should be used to pump liquids, especially dry ones. But in case there are any, because of process upsets, there are any liquids that come in, there is a decent enough capability available within the pump through which the pump can pump these liquids as well. The advantages the pump offers the advantages that the pumps offer is very high pumping speeds. It has a robust design. Maintenance cost is low. Volumetric efficiency is very high. And again, this pump also offers the same advantages that are of 100% dry pumping. Now we'll go to a very important topic, which is optimum operating condition. So how do you decide and how do you define optimum operating condition? When we are doing dry pumping, internal temperature profile of dry pumping becomes very crucial. Now, what is internal temperature profile? A smooth and gradual compression ensures that process gas is maintained in vapor state without the risk of condensation, polymerization, autoignition, and other effects of heat. The other important point is a well-designed dry process will not suffer from the problem of compatibility of process gases as opposed to wet pumps. Now, if we operate the pump too hot, Still there is problem of polymerization, auto ignition. If we run the pump to cold, there is still problem of condensation, there is still problem of liquid pumping. So it becomes very important for any dry primary pump. Again, I will repeat, this is not applicable. It is advantageous for the booster if booster also operates in this range, but this is majorly applicable to any type of primary dry pump. Any manufacturer, any design, all dry vacuum pumps should typically be operated in optimum operating condition. What will be the advantage, or how do you decide that what is the optimum operating condition? Three conditions should be met. Number one, there should be no condensation, there should be no corrosion, and there should be no polymerization. Then we can say that we are operating in this green band. We are either operating in red band, that is also a problem. We are operating in the blue band, that is also a problem. Next is a curve which is a characteristic of how our pump behaves as compared to a conventional dry vacuum pump. So the line that you see in red will be typically for a conventional vacuum pump. The same way you have three stages that are there over here. In this phase, there is all liquid. In this phase, there is all vapor. And here there is evaporation that is there. And here there is condensation. So by virtue of how pump behaves, you have suction, that is point number one, where you are picking up from the process in a chemical process industry. Typically here it is say 20, 30, 40, whatever millibar. At point number two, where the initial compression starts for the first pitch, there is compression happening. That compression, because this is a hybrid variable pitch, there is continuous compression happening within the pump. It passes through to point number three and you reach at this stage. Now at this stage, against the discharge plate, there is a compression plate against which maximum compression takes place, and there is sudden rise in temperature. Because of this compression, there was a probability that condensation might have taken place, because it is like LPG, liquid petroleum gas. When you compress gas, it converts into liquid petroleum. But as soon as you let it expand, it converts back into gas. Similarly here, because of the heavy compression at this point, there is a possibility that condensation might start occurring. To cope up with that, what we have done, we have changed the last two pitches so that we compress, we give a sudden jerk in compression to raise the temperature and ensure that there is no condensation happening within the pump. So I have tried to explain it in words also. Here, the most important point is, so I'll go from point number one. Dry pumps operate very efficiently when operating in vapor phase and do not face any problem of corrosion or contamination. This is because pressure and temperature profile are maintained above the dew point of the process media, ensuring reliable operation even when pumping highly corrosive mediums. So till the time you are pumping above the dew point and ensuring that there is no condensation happening within the pump, you can be rest assured that there will be no corrosion happening within the pumps. The advantage of dry pump solvents can be recovered easily by use of post condenser and recycled without need of any purification, because there is no contamination that happens within the pump. For this reason alone, dry pumps are particularly a good solution for processing organic solvents and corrosive vapors. Keeping corrosive vapors in vapor state has proven successful for many years. That is the key, how we can keep vapors in how we can keep corrosive vapors in vapor state and not let them condense. So the hybrid variable pitch is an ideal choice when it comes to that, because the pitch of the screws has been optimized to ensure that the pump that the vapor is getting adequate amount of heat and does not condense. Majority of the dry pumps that are there in such cases are ductile irons, and internals in most of the cases are coated as an extra protection to cope up with process upsets. So now what I have tried to explain you is that even though dry pumps, if they are in vapor phase, the process vapor is in vapor phase, can run without any problem of corrosion. But no customer can be 100% sure. So as an extra protection, we tell the customers that we offer to cope up with whatever process upsets that are there. As an extra safety, it is always sensible to have internals coated. These can be either polymer coating, such as PEEK coating, PTFE coating, or they can be plating, such as nickel plating. Now coming to the next chapter in our webinar on some particular case studies and the rule. So we have covered classification, we have covered categorization, we have covered wet technology, what all pumps are available in wet technology specifically to chemical and chemical process industry, what pumps are available in dry technology, what are the do's and don'ts, what are the advantages, what are the disadvantages. Now I am going to the next part of the presentation, that is how optimization and what you should be expecting. The 2030 rule, as we call it at Everest. So at Everest, we believe that by right focus and approach, in most cases, customer should target to reduce his operating cost by 20% or more, benchmarking existing cost, and target to increase his productivity by 30% or more by benchmarking existing conditions. This is the experience we have gained over the years when we have dealt with various more than 1,000 customers, documented readings, documented case studies. We realized that 2030 rule applies to more than 80% of the customers that we cater to. I will now take up some case studies in brief. Because of shortage of time, I will be taking them up in brief. This is a particular customer, GFL, Gujarat Fluorochemical Limited, wherein their manufacturing is for monochlorobenzene and sulfonyl. The process is distillation under vacuum. Typically, what we have offered to the customer is a 1000 meter cube per hour system running at 5 torr. The older system that the customer was using was a 3-stage steam jet ejector with an intermediate condenser. What we have offered is a super vac with a post condenser. Now, if you see a wet system, that is a steam jet ejector, versus a dry system, here the operating cost that the customer was incurring annually was about 28 lakhs, which we have been able to reduce to almost 9.76 lakhs. In total, if you talk the direct savings, this is only direct savings, the 2030 rule, direct savings, he has been able to save 18.88 lakhs. Now, if I put a percentage onto this, he is saving 65% of what he was actually spending on utilities. The other advantages that the customer is getting, earlier batch time was 22 hours, now reduced to 18 hours. Now, I can't put a value onto this as to what are the actual monetary savings, except for the enhanced saving in terms of production, because from the same capital infrastructure, that the customer has, he's getting more than 20% more production. His purity levels earlier were 98 to 98.5%, which are now 99% plus. And solvent recovery that the customer is getting is approximately of 5.4 lakhs per annum. Now, I don't consider this 5.4 lakhs as a part of the utility. This is an additional saving that the customer is getting. Similarly, I'll take another example of another customer, which is in cardinal oil distillation. So this customer was monochlorobenzene and sulfolene distillation, and here it was distillation under vacuum. In this also it is distillation under vacuum, but it is a totally different field. It is a wide film evaporation. That was a batch process. Here the customer is using 7,000 meter cube per hour pumping speeds. Vacuum levels are much higher. What we have offered to the customer is a SuperVac 7000 with a intermediate condenser. What the customer was earlier using was a 3-stage ejector with a mechanical vacuum booster. Now this benchmarking is with a semi-dry, because he was already using 2 mechanical vacuum boosters versus completely dry. Here for 7,000 meter cube, the customer is saving 22.79 lakhs. If I put a percentage to it, he is saving almost 58.18% in terms of direct utility cost. In addition to this, in terms of productivity, what the customer has gained, his production has increased from 11 ton. It has gone up to 13 ton. In the previous example, we discussed cycle time has come down from 22 hours to 18 hours. In this particular, his production has gone up. Apart from production, his yield has also increased. So earlier he was only able to recover 60%, which has now gone up from 60 to 63 to 65%. These are all, so here I am not even putting a value right now, because these figures alone run into crores of rupees. And in such cases, most of the customers are using multiple vacuum systems from us. Like GFL, we have given more than 11 vacuum systems. Every vacuum system you are consuming, say you are saving 19-20 lakhs, multiplied by 10 systems, 11 systems, you are saving more than 2.5 crores. Solvent, so similarly here, solvent recovery, customer is is almost saving 3.6 lakhs in direct solvent cost that he is able to reuse back into his process. Now, similarly, I have again taken another varied example of another field, which is a biodiesel field, where the customer is Matrix Fine Sciences. The product is alpha tocopherol and biodiesel. Here again, distillation is under vacuum. Pumping speed is 10,400 meter cube per hour. Vacuum is 0.5 torr. Customer was earlier using a 4-stage steam jet ejector system, which has now been replaced by 10,400. This is the type of system that we have replaced it with. Now, if I make a comparison here, again, customers' total direct saving that the customer is getting. Okay, so we categorize at Everest or at our TSG, we categorize into 5 major heads. First is the power. Any type of power that the customer, whether be it electric, steam, any type of power. Then is utilities. Third is solvent recovery, what the customer is actually saving. Fourth is the air utility or nitrogen that is typical only to Everest dry vacuum pumps or any dry vacuum pump for that matter. And fifth is the maintenance cost that the customer is actually incurring. Here, if we calculate, customer was earlier spending almost 47 lakhs, 46 lakhs in direct utilities, which by installation of a dry vacuum system has dropped to almost 1/3 of, it has come to a figure of 16.77 lakhs. A total saving that the customer has been able to do in this particular case is of 63% in direct utilities. Let's see what he's been able to save in terms of productivity. So batch, earlier he was completing in 18 hours. He is now completing that same batch in 16 hours. So solvent recovery also, he was earlier solvent, he was not being able to recover. All of that solvent was getting mixed and flowing along into the effluent. Here he is able to save directly solvent of about 3 lakh rupees per annum. So till now we have covered three different varied examples. First example was for a agrochemical or a super specialty chemical industry. The next example was for a cardamom oil or a end product manufacturer. The third example that we've covered is for a biodiesel refinery and varied vacuum levels in all cases. Next example that I am going to be covering is going to be something interesting. This is from plant lipids. Now this is curcumin. Curcumin is basically a specialized oil which is used as a antibiotic oil. It is being manufactured by plant lipids. Here the customer was extracting hexane and ethyl acetate from curcumin. He was earlier typically using a 300 meter cube per hour booster pump, steam jet ejector, rotary wing pump, and that pump he has replaced with a 300 meter cube per hour steam jet ejector from Everest. Now here the system or the pump that the customer was using, rotary vane, which was a wet technology, because the size of the pump is too small, the savings that the customer is in terms of monetary value, if you see, are only 4.64 lakhs. But in terms of percentage, if you see, he is able to save almost 45%. So that is the amount of difference or trend that you can see. So if you have say 30 or 40 pumps installed in one installation, the amount of money that you can save by just making one decision of shifting from wet technology to a dry technology, we have been able to place. Anybody who has any more questions related to this, there is a detailed sheet that we have in which we do these whole costing analysis. You are most welcome to get in touch with us, and we'll share in detail on what are the benchmark figures that are considered over here. But these are typically benchmark figures that have been gathered from the industry. Now here, in terms of productivity, if we talk, the advantages that the customer had: time saving. Earlier, customer was doing 12 hours batch. Now he's doing a 10-hour batch. Quality of the product, product purity, earlier that he was being able to achieve was only 96%. Now he's being able to achieve a product purity of 98%. Another example, which is an ongoing discussion for us with one of our customers. Customer has placed a RFQ for 11 such systems. So this is Cadbury Mondelez, where he is currently using a dry a steam jet ejector system, which he wants to replace with a semi-dry, not a completely dry, because here we are offering the customer a liquid ring pump with closed loop recirculation. Customer will be using 3500 meter cube per hour system running at 25 torr ultimate process running vacuum. We on our calculations are able to provide customer a saving of 16.13 lakhs, which is again approximately 65% in total direct saving cost the customer is saving. The advantages that the customer will get with this, with making this modification, apart from the direct savings in utilities, he will be able to reduce his cycle time from 145 minutes, bringing it down to about 125 minutes. Customer will improve his product yield, recovery, and will also improve on the product quality. One more case is of PVG group. Here again, the capacity of the system is big and the vacuum requirement for the customer is high. Customer is currently using a 4-stage steam jet ejector, which we are proposing to shorten to 1800, which we are wanting to replace with a SuperVac 18,000. Here we anticipate drastic saving for the customer. He will save almost 88.51 lakh rupees, which if I talk in terms of direct utility cost, the customer will save almost 72. So from 1.22 crores that he is currently spending, he will only need to spend 33.79 lakhs. Save it 27. So out of 100, he'll only be spending 27.63%. 72.327% will be the saving that the customer will get. Mainly, these are the heads where the savings are anticipated. So mainly in terms of consumption of steam, will the customer anticipate these savings. Other benefits, because this is still a system which is under consideration, benefits that the customer will anticipate is cycle time reduction. Definitely he'll get cycle time reduction. Product yield recovery improvement. Steam jet ejector, the biggest challenge is fluctuation in vacuum. Dry systems, that fluctuation in vacuum vanishes. So stability in product quality becomes very nice. Because of this stability in product, the ultimate product quality also becomes very nice. Some industries where this rule of 20-30 applies. So chemical and pharmaceuticals, electrical industry, vacuum furnace industry, industrial processing, all heads under industrial processing, and food processing industries. Now, one concept that is very important over here is total cost of ownership and how to make right selection of vacuum pumps. Vacuum pump cost of ownership can be categorized into 3 categories. One is the capital cost, then is the installation cost, and then is the operation and the maintenance cost. Now I have taken, this is data that is annualized cost of ownership for chemical process industry. This is a published data by American Institute of Chemical Engineers. I have taken this data from there. If you see, typically this is the first bar that is there is of a steam jet ejector. This data is in terms of pounds. So 3.27 million pounds is what you anticipate your cost of ownership to be for the first 5 years, year 1 to year 5. So the first is the initial cost and then is the operational cost. For a rotary vane vacuum pump, this is the cost that you anticipate. For a liquid ring vacuum pump, in this process, they have presumed that the evacuation that they are doing is also of similar nature, is this. Then comes the dry claw vacuum pump, where the cost of ownership comes to $98,000, and then comes the dry screw vacuum pump. where the total cost comes to about $76,000 total cost over a period of 5 years. So from 3.27 million versus $76,000, that is the effect that you can get over a period of 5 years. So why not only capital cost but installation as well as operational and maintenance cost become important? You can see very clearly from this graph. The final choice of vacuum pump should be based on the total overall cost of ownership. Typically, in case of dry vacuum pumps, the return on investment is anywhere between 1 to 3 years. Now, here we have done segmentation of various industries and what all, in which all industries, which type of vacuum pumps are best suited. Again, keeping in mind the capital cost, the installation cost, and the operation and maintenance cost. So as you will see, the mechanical, the first two are the dry pumps, and the last four are the wet pumps. Even though these pumps may be slightly cheaper in first cost, but once you calculate and change your thought of calculating total cost of ownership over life cycle, you will realize that dry pumps are way more economical as compared to wet pumps. So we will be sharing this presentation with all of you. All of this will come. These are the various segments where these pumps are popular. And as you can see, in most of the applications, dry pumps are or can be a good choice. Green category specifies low cost of ownership, medium cost of ownership, and then you have high cost of ownership, calculated over a life cycle, typically 5 years. Now conclusion. So wet versus dry technology. Dry vacuum pumps are getting established as efficient and reliable option for demanding chemical and process industries. As dry technology is continuously evolving, there is continuous advancement happening. Dry technology is becoming a preferred choice simply because of lower total cost of ownership. They are becoming popular choice in some of the most aggressive and problematic gases, around in a broad range of processes. Chemical processes are now placing new demands on the market, driving an emerging trend for vacuum to be seen as a utility, highly reliable, flexible, available on demand in plug and pump mode systems that require minimum setup and maintenance. 15 years back, you had to buy a separate mechanical vacuum booster, a separate dry screw, a separate vacuum pump, backup pump, a separate panel. It was just in the last 15 years that aggregators such as EverestVacuum came in, who started packaging the whole solution, offering the whole solution as a utility, plug and pump, requiring least maintenance, properly sized vacuum systems. When processes are specifying new vacuum systems, today we talk of total cost of ownership and environmental impact, which become the key deciding factor to choose the right type of vacuum pump. Now I welcome all of you. We are offering to all of you who are attending the master class today a free one-to-one call. What you just need to do is you need to log in to this tinyurl.com/EverestVacuum-TSG. a Google form will open up. Please register yourself, and we will organize a 1:1 strategy call back with you, wherein we will understand your specific problem and offer to you our expertise opinion as to if we would have had been in your place, how we would have acted. Coming to the last topic is contamination in vacuum systems and its control. So because of shortage of time, I don't think I'll cover this topic right now. I have already covered this in the previous webinar, but I will be sharing this through slides. Rakesh ji, am I audible?
Yes, please. Absolutely. Dhruv, you are audible.
Okay, so this is contamination in vacuum systems. These are some of the contaminants. If we have time on that day, probably I'll try to reduce some slides in between. Then we'll cover this topic. Otherwise, we'll share it with the people. We have already covered these topics. So contamination and 7 golden rules for vacuum pump maintenance. These are the topics, and then we open up for Q&A. So that's going to be the flow. Yeah. Good. I think all can unmute yourself. All can switch on your cameras, and we can have our discussion, and then we can move forward. Yeah.
Absolutely. Yes. Team, go ahead and quickly unmute yourself and switch on your camera, so we can collaborate. Yeah. Anybody, anything, Pranju, you want to take a first go? Anything you want to comment on?
No, sir.
अभी भी मेरे को लग रहा है हमारी presentation बढ़िया है. I thought we'll be able to cover 1 hour, but I think it's gone 1 hour and 16 minutes.
Rakesh ji,
Yes, go on, Devraj.
some customers ask this presentation. I think you're not eligible, no, to provide that. Last presentation, what happened? So, like Pharmagel asked for the presentation.
Well, we had allowed people to register and download.
Okay.
What people can do, Devraj,
Yeah.
we have created a link on our website. People just need to go there. They need to enter their details. And as soon as they enter their details, they'll get a copy of the video of the presentation also, as well as the PDF copy of the presentation.
Okay.
So what we'll do, probably, you can share that link with him.
Yeah, we'll get that organized. Okay.
Okay, right.
Yeah. Reach out to Chetna and she will support you on that part.
Okay.
Right.
Thank you.
All right. Any other observations, comments, team? Anything that you think
or any specific topic that you want me to cover apart from this? The theme this time was chemical dry pumps specific for chemical and process industry.
Sir, I feel everything is intact. The time taken maybe 1 hour 15 minutes, but hello, sir, am I audible, sir?
Yeah, you are audible.
Yeah, though it has taken 1 hour 15 minutes, the inputs this time on the explanation given is quite elaborate, which is nice. Compared to what I observed compared to the previous session, this time the explanation part is improved, increased, and the command on the entire explanation is also reasonably commendable. This is what I observed, sir.
Good.
Anything else, Ravi, you want which could be incorporated, or you think we might need to tweak or add?
Sir, as of now, compared to earlier in the previous webinar, we have covered only one case study. but in this we have covered a lot more. So the many cases have been confirmed, and see, the basic idea would be how much ever we talk on these webinars, but finally the one-to-one session will give a better solutions to the end users, and this particular webinar is quite good enough and sufficient enough to attract the customer towards Everest. This is my submission.
Can I say, Rakesh ji?
Absolutely. Please go ahead, Devraj. Yes.
Overall, the technology about the dry screw compared to steam jet and other applications we are discussing. So I'm not sure whether it is suitable or not. Attracting to towards the companies who are present in India, who are supplying the dry screw vacuum pump, and we can have a specific on our product why it is why customer will prefer for the only Everest. Any?
See, I get your point. I understand where you're coming from, but broadly, you see, those are detailed discussions which need to be pursued on a case-to-case basis. Now, we cannot start comparing ourselves with competitors on a global platform like this.
Yeah, exactly. What I thought that way.
Yeah, so we can't do that on this forum, at least.
Yeah, right.
And the only way to address it is a one-to-one, either with potential customers or even if they don't have any requirement, and if they're using competition and we feel that they could be potential for later on, sure, if we are able to engage with them, then we continue to engage with them to build up trust and confidence in our commitment to be able to serve them preferably better versus the kind of support they're getting from competition currently, right? So all these tools are important for us to be able to start sending out the right messaging to customers that we are one of the key players and we can bring value to their processes, right?
Yeah,
so
right.
Specifically the 2030 part that Dhruv has spoken about is excellent in terms of driving that correct messaging across to the customers in terms of differentiating us subtly versus competition, right?
Yeah,
So
right.
not directly comparing, but we say that this is the kind of added value we do. And then when we go to the customer at a 1:1 level, then we can bring in direct, the competitive edge that we have.
Yes, right. Okay, thank you.
You see, I would like to add a little over here. What is important or what we want to tell our customer is that he should not look at us from an equipment supplier point of view.
Yeah.
Rather, he should look at us from a collaborator point of view, wherein we open up all our cards with him, he opens up all his cards with us, we truly collaborate and we move beyond the equipment. Equipment is one part. But if we move, equipment is what? 7 lakhs, 10 lakhs, 20 lakhs, 30 lakhs maximum. But if you are talking of the bigger picture, you are saving in crores.
Yes,
in
right.
One pump itself, in one utility itself. In terms of enhancement in productivity, one customer is putting a 10-ton plant. He's producing, say, 10 tons per day. Okay. Now, he has put that 10-ton plant for, say, 30 crores, 20 crores, whatever he has invested in land, he has invested in machinery, he has invested in stock, he has invested in manpower, he has invested in XYZ. Total, he's put 30 crores or 20 crores. If we are able to increase that 10 ton to 13 ton per day, we are giving him almost 30% increase in his production.
Exactly. Okay.
30%. And what is the initial investment that he has to do? Maximum 20 lakhs, 25 lakhs, 30 lakhs per system.
Yes.
So the saving that he is getting, nobody is right now realizing this. And the more when we talk to the customers, the more we feel that there is a gap. So we want to start telling our customers to think beyond equipment and move on to vacuum thinking of vacuum as a utility.
Utility and solutions, yes.
Yes.
Solutions.
Yes.
Exactly. Okay.
Yeah.
I think overall it is a bigger way of, I mean.
Yes. So any customer is telling
collaboration, collaborative.
See price, उसे बोलो price sir, price तो एक बहुत छोटा part है. जो मैं आपको समझाऊंगा उसके सामने price is nothing.
Exactly. Right.
So our purpose of this webinar is to pass this message to our customer. And through all of you also, I want to pass the same message to our customer that if you don't know anything, no problem, tell us. At least we'll be open and we'll start collaborating. We'll share information freely. You see, we are interacting with more than 1,000 customers. So we have a lot of knowledge. Maybe we are able to add some value to that customer in whatever smallest way. But at least we are giving him something now.
Right. Yeah.
Yes.
So it is beyond selling.
Yes. You see, selling, our job through these mediums is not to sell material. Our job is to create a buying environment. Once a buying environment gets created, once the customer understands and acknowledges that yes, these people know their job, he will automatically come back to us. Our job is to establish ourselves as a authority in the field.
Yes.
Once we are able to do that, customer will automatically come back to us.
Exactly. Yes, correct. Right. Okay. Thank you.
Anybody else? Team? Anybody with any other viewpoint or comment, suggestion? Any feedback?
Yeah, this time I started a day earlier because last time I got so many comments. I thought I'll put in more masala to the presentation. अभी तो काफी stereotype और मेरे को लग रहा है content काफी ज़्यादा है, but we can further.
No, I believe the content is extremely interesting.
Yes.
And quite engaging, because especially when you come into the part where we start engaging with customers on the different under different processes, the kind of savings that we have done and showcased to customers, the live examples that we start talking about, I think that part is extremely engaging. Extremely engaging.
Yes.
And that would give them the right level of confidence that not only are we on top of the game, but we are willing to engage. We are willing to talk about it as well at a global level. Usually, most suppliers, if they want to, kind of hide whatever they do with themselves, then they will stop engaging. Now here, not only are we talking about, having a good understanding of a vacuum as an industry vertical, but also we are willing to engage and take that learning and utilize it for the larger good, right? And we're not charging anything, so that's also a plus. Yes. That's a huge plus.
Yes,
that's a huge plus, and a very good differentiator versus our competition. So that's something that guys, entire team needs to view it from that point of view. And when we engage or we talk in terms of bringing in participation, or henceforth, as we start doing these seminars from a regional point of view, and like I told you today in the morning, that next time onwards, we'll have to start doing it ourselves, right? So each region will have to start driving their own activities. And of course, we will take Dhruv's input and support in terms of either content or supporting us as a panelist on these forums. But broadly, we should be able to drive that message right from the point of inception of saying that, okay, we are wanting to do this webinar and this will add value. Please come in. That's the pitch which we should take. That you come in, you spend about an hour, and you will walk out with some serious, output, which will help you maximize or minimize your costs and maximize efficiency in your plants going forward. So that's the kind of messaging that you need to guys take from this, the first forum and the upcoming second forum, and then continue to make sure that you harp on the same thing again and again and again with all our customers, right?
So one more observation. Normally, when Mr. Drumalhot addressing the webinar, normally his background is shown as the office only. So what is the possibility of taking some green? I don't know how it is done, but normally if some green background support is taken, if our logo or our machinery, yeah, exactly, sir.
Okay. I am in San Francisco, so as jitni तेज आप सोचोगे, I am in a cafe. All that is possible in Zoom.
Ravi, you want
Thank you,
something
boss.
more?
You are our boss. No, said boss. Thank you, boss. You are our boss.
Chai yaar. Tea.
Excellent. Yeah. Now you got the cafe background. Excellent. All right. Okay. So good observation, Ravi. Anybody, team? You want to comment, guys? Where are we on the registration, Chetna? How many number of people have registered with us till now? Chetna, can you unmute yourself? Chetna?
Hello?
Yes, Chetna. Chetna, how many registrations till now?
The last time when I checked, it was 35 around.
This time, okay. In the morning, it was what, 27, 28. So it's only improved a few notches to 35.
Yes.
All right. Nonetheless, guys, let's go into that 1:1 mode, right? Like we did last time. Let's get into the overdrive starting from now, and make sure that we overcome the last time's complete registration of 209 participants, right? So eventually the number of people who came on board was lesser, but at least we had 209 registrations. So let's make sure that we are able to drive it much more than that. Broadly, we had 2,400 invites last time. This time we are already touching about how much, Chetna? 3,300 plus?
3,100.
Net off.
Yes, sir.
I thought it was 3297, right? No? Or there was still an error somewhere?
Rakesh ji, 1 minute.
Ji.
You see, team, what I would like all of us to emphasize upon, this strategy call, there are two ways for us to do it. Either we put a price tag to it and we offer it to our customers for free, or we offer it to them for free. What is very important is for us to engage them into these strategy calls with us, because once we are able to get them to share their data with us, we will be able to give them very good insights and we'll be able to greatly add value into their processes. Like last time, we got a lot of questions, we got a lot of feedback, but I think the strategy call, we got only 2 people to fill it up. This time we would like to increase that so that that can act as a lead generation for your zones, individual zones. Right?
Absolutely, valid point. You're right, absolutely. Spot on there, Dhruv. I agree. Absolutely.
Here, this is ultimately our aim of this webinar is to establish ourselves as a authority. B, to be able to get people to engage with us so that we can get good quality leads out of this. Okay?
Absolutely.
Chalo, I'll just take a 1 minute break here. You can continue or
Sure.
Yeah.
No, sure. We can continue to engage. Sure. Go ahead and take a break. Dhruv. Yeah. All right. A team. Can you quickly unmute yourself, everybody?